As a woman in submarine engineering, no one trusted her. Technical work is men's work, they said. Until she was 800 meters deep in the Atlantic, when the nuclear reactor malfunctioned and the entire crew's lives fell into her hands. At that moment, no one cared about her gender. Lieutenant Sarah Catherine Morgan's submarine career began at Norfolk Naval Base. At 24, a nuclear engineering graduate from MIT, her family had 3 generations of naval history. But Sarah would be the first female submarine officer in the family tradition. Submarine selection was a grueling, months-long process. Not just physical tests, but psychological endurance, claustrophobia tests, and technical competency exams. Sarah had successfully passed every stage, but the real challenge would begin after selection. "Morgan," said Captain Robert Hayes, chairman of the Submarine Selection Board, "your file is impressive. Summa cum laude from MIT, thesis distinction in nuclear engineering. But submarine service, it's a completely different world." "Yes, sir, I'm aware of its challenges. As a female officer in submarine service, you'll face unique challenges. Crew reactions, living conditions, operational stresses." Sarah straightened her posture. "Sir, I'm focused solely on becoming the best submarine engineer." When assigned to USS Phoenix nuclear attack submarine, the crew's reaction was cold and distant. Submarine Commander James Mitchell was an officer with 20 years of naval experience and an old-school approach. "Morgan," he said during their first meeting in his office, "this submarine has been in service for 30 years. Crew traditions, established procedures, tight-knit brotherhood bonds. Your presence will change the dynamics. Commander, I've only come to do my job to the best of my ability. I specialize in submarine nuclear systems." "I know your file, Morgan. Academic record is impressive. But there's a big difference between classroom knowledge and life-or-death decisions at 400 meters depth. Especially for a female officer, there are additional pressures." Chief Petty Officer Marcus Thompson, the engineering chief with 15 years of submarine experience, was an experienced and tough officer who took a clear stance with Sarah. "Morgan, submarine engineering is no joke. Reactor operations, emergency protocols, hydraulic systems, life support equipment. Every decision can affect 120 lives." "I understand, Chief. I received comprehensive training in submarine nuclear systems, reactor physics, thermodynamics, emergency procedures. Textbook is one thing, real world is another, especially for female officers. Extra scrutiny, additional pressure, mistakes are more visible." Sarah's first days on the submarine were mentally and physically challenging. Narrow corridors, limited privacy, constant noise, but the hardest part was the crew's constant testing. Reactor Technician Petty Officer, First Class David Wrench Williams, a 12-year reactor operations specialist, constantly tested Sarah's every piece of knowledge. "Morgan, what are the normal reactor coolant temperature parameters?" 545 to 550 Fahrenheit range, Williams. Current reading is 547 inches. Primary loop pressure specifications, 2,200 to 2,300 psi normal range. Currently, 2,250 inches. Steam generator levels optimal percentage, 65 to 75% normal operating range. All 4 generators currently at 70%. Control rod positions critical parameters. Full withdrawal, maximum reactivity. Incremental insertion for power control. Current configuration appropriate for normal power operations. Williams nodded, but his facial expression remained neutral. Sarah's knowledge was comprehensive, but practical experience was lacking. Electronics Technician Petty Officer, Second Class Mike Sparks Rodriguez also tested Sarah on electrical systems topics. Morgan, main electrical switchboard emergency backup procedures. In case of primary power loss, automatic switchover emergency diesel. Manual backup battery systems, load shedding protocols for essential systems. Emergency procedures for lighting circuit failures. Emergency lighting automatic activation. Backup battery systems. Handheld portable lights secondary backup. Every day, new questions, new tests, new challenges. Sarah answered every question correctly, but earning the crew's trust would take time. One evening, in the mess hall while eating, Sarah overheard the conversation of Petty Officer Williams and other technicians at a nearby table. Woman, engineer in the reactor compartment. I mean, can she really handle pressure in an emergency situation? Different ballgame. Submarine engineering, said electronics technician Rodriguez. Book smarts is one thing. Split-second, life-or-death decisions are a completely different animal. Plus, living conditions in tight quarters, shower schedules, sleeping arrangements, personal space issues, could create complications for operational efficiency. Sarah heard the comments but showed no reaction. She maintained professional demeanor. She knew she had to prove herself through actions over time. The first major challenge came during a routine maintenance operation. Primary coolant pump bearing replacement, an extremely delicate procedure requiring precision engineering and perfect coordination. Chief Thompson gave Sarah operation leadership. Morgan, this is your first major maintenance command. Mistakes are not tolerated in submarine operations. Don't screw up. Sarah did detailed planning. Reactor shutdown procedures step by step, coolant system isolation protocols, pump removal sequence, comprehensive safety precautions. Every aspect critical, no room for error. Williams, Rodriguez, are the pump isolation valves ready? Valves aligned, Morgan. Primary coolant flow secured. Radiation levels in the reactor compartment. Normal background levels, safe for extended work period. When the operation began, Sarah's team coordination was perfect. Clear instructions, safety emphasis, obvious professional competence. Crew members gradually began to be impressed. Halfway through the operation, an unexpected complication developed. The bearing housing was damaged during removal. The replacement part had slightly different specifications. Williams approached with concern. Morgan, the new bearing dimensions aren't an exact match. Installation could be risky. Tolerance margins are tight. Sarah examined detailed specifications, performed engineering calculations, carefully evaluated safety margins. Technical expertise was on full display. Tolerances are within acceptable range. Installation is possible, but extra precautions are mandatory. Must modify torque specifications. Additional testing required. Are you absolutely sure? Mistakes in reactor systems could have catastrophic consequences. Completely confident, Williams. Calculations are solid. Safety margins are sufficient, but we'll proceed carefully, step by step. The operation was successful under Sarah's leadership. Reactor restart was smooth. All systems returned to normal parameters. Chief Thompson was visibly impressed. Outstanding work, Morgan. Leadership under pressure was exceptional, technical competence proven. But the crew's real acceptance had not yet come. One successful operation wasn't enough proof in a submarine environment. After 3 months of intensive training and routine operations, USS Phoenix was assigned to a critical mission. North Atlantic Patrol, Strategic Area Monitoring, Classified Objectives, 60-day extended deployment. At the mission briefing, Commander Mitchell explained the situation to the crew. Gentlemen and lady, this patrol is not routine. Strategic importance is high, operational risks are significant. Extended submerged operations, deep water, potential hostile contacts. Sarah took a critical role in reactor watch rotations. Systems monitoring, parameter checks, maintenance oversight, emergency preparedness. Submarine engineering had become second nature. The first week of patrol was routine transit, submerged navigation, standard depth 400 feet, normal patrol operations. Sarah handled watch-standing duties with professional competence. The second week brought challenging weather conditions. Surface storms affecting submarine operations even at 400 feet depth. Additional stress on systems. Careful monitoring required. Morgan, are reactor parameters being affected by storm effects? Chief Thompson asked during watch change. Minimal impact, Chief. Coolant system stable, power generation consistent, storm effects negligible for reactor operations. In the third week, operational tempo increased dramatically. Deep dive orders, maximum operating depth approaches, evasive maneuvers, classified mission parameters. Dive, dive, dive. Make your depth 750 feet. Maximum angle exclamation mark. The submarine went into emergency dive attitude, depth rapidly increasing. 750 feet near maximum operating envelope, enormous pressure on systems. Sarah performed critical monitoring at reactor control. Deep water operations put significant additional load on reactor systems. Primary coolant pressure compensation, power output adjustments, emergency systems readiness. Reactor department, status report. Reactor stable. All parameters within acceptable limits, Sarah responded confidently. Power output steady, coolant system successfully compensating for depth pressure. Hours passed in tense atmosphere, deep patrol operations, extended duration, increased system stress. Sarah maintained meticulous monitoring. During the night watch, Sarah was alone on duty at reactor control. Quiet periods are dangerous in submarine operations. Vigilance is always critical. Subtle system changes can easily be missed during fatigue. Radar technician Petty Officer Johnson stopped by reactor control. Morgan, long watch tonight. Everything smooth? All systems green, Johnson. Reactor parameters steady, no issues. You're handling deep water operations well. Impressive for first deployment. Thank you. Training was comprehensive, but real experience is valuable. The crew is talking, Morgan. Initial skepticism is changing to respect. Your competence is obvious. This conversation was an important milestone for Sarah. Crew acceptance was gradually building. Professional recognition was emerging. On the 16th day of patrol, the mission suddenly escalated. Emergency dive orders, maximum depth, evasive actions, threat level elevated dramatically. Emergency dive. Emergency dive. Make your depth 800 feet, all ahead flank. 800 feet was extremely close to maximum operational limit. Pressure tremendous. Systems stressed to maximum. Emergency protocols activated. Sarah performed intense monitoring at reactor control. Depth pressure significantly affecting reactor systems. Coolant circulation challenged, power demands at maximum. Engineering, reactor status. Reactor responding to emergency power demands. Systems stressed but stable. Monitoring all parameters closely. Hours passed at maximum depth. Sarah maintained constant vigilance. Every parameter carefully watched. Fatigue was setting in, but professional discipline was maintained. At watch change, Chief Thompson came to reactor control. Morgan, situation continues. Extended deep operations likely. How is the reactor holding up? Systems functioning within acceptable parameters, Chief. Coolant pressure compensating for depth effects. Power generation meeting demands. Any concerns about approaching operational limits? Monitoring closely, but current status is sustainable. Backup systems ready if needed. The morning of the 17th day, routine watch beginning seemed normal. Sarah was performing standard checks at the reactor control panel. Primary loop parameters, secondary system status, backup equipment readiness. At 7:43, what every submarine engineer fears happened. Multiple alarms activated simultaneously. Red lights flashing, sirens screaming, parameters rapidly deteriorating. Reactor emergency! Reactor emergency! All hands to emergency stations! Sarah's blood froze. Reactor emergency was the ultimate nightmare on a submarine. Control panel chaos, alarms deafening, systems failing rapidly. Primary coolant loss. Major breach in reactor coolant system. Pressure dropping catastrophically. Temperature spiking dangerously. Sarah immediately activated emergency protocols. Emergency reactor shutdown. Scram all control rods. Activate emergency cooling. Chief Thompson came running to the reactor compartment, other technicians following. Emergency response team full activation. All hands to emergency stations. Morgan, complete status report. Chief, major primary coolant leak. Pressure dropped 45% and falling. Temperature rising rapidly. Emergency cooling activated but insufficient. Commander Mitchell quickly arrived at reactor control. Engineering, what's our exact situation? Thompson rapidly studied the control panel. Skipper, catastrophic coolant leak. Rate of loss is unsustainable. Without immediate repair, reactor shutdown mandatory within minutes. Meaning? Dead stick in 800 feet of water. No propulsion, electrical power failing, life support systems compromised, emergency surface impossible at this depth. Dead stick was submarine terminology for worst-case scenario. No power, no movement, gradually sinking, crew survival limited. Repair options. Leak location must be identified, emergency repair attempt, but radiation exposure extreme, access dangerous, success uncertain. Sarah rapidly studied reactor schematics, trying to determine leak location. System knowledge, technical training, engineering expertise at critical moments. Chief, leak source identified. Primary coolant line sector 7, main circulation loop, major pipe rupture, high pressure loss. Is repair feasible? Emergency patch possible, temporary seal achievable. But manual access required. Someone must enter the reactor compartment. Thompson grimly calculated. Radiation levels in lethal zone. Exposure in minutes, career ending, potentially fatal. Volunteer mission only. Silence filled reactor control. Radiation exposure was the submarine engineer's ultimate sacrifice. Career destruction, health risks, potential death. Sarah resolutely stepped forward. I'll go, Chief. Negative, Morgan. Too dangerous, too risky. Experience insufficient for emergency repairs. Chief, my reactor system knowledge is most comprehensive in the team. Technical expertise optimal for repair success. Commander Mitchell seriously intervened. Morgan, I understand your capabilities, but radiation exposure levels. Commander, 120 lives are in immediate danger. Someone must attempt a repair. I'm the most technically qualified engineer available. Morgan, radiation poisoning is irreversible. Career over. health permanently damaged. Commander, I took a submarine service oath. Crew safety comes before personal risk. Chief Thompson's final assessment. Morgan, if you volunteer, maximum exposure time is 15 minutes absolute limit. Beyond that, radiation poisoning guaranteed fatal. Completely understood, Chief. Repair procedures memorized, emergency tools ready, technical approach planned. Crew members in reactor control watched in silence. Historic moment. Female engineer volunteering for suicide mission to save crew. Williams approached Sarah. Morgan, respect. When you first arrived, there were doubts. Now, you've proven you're a real submarine engineer. Thank you, Williams. This is teamwork. Rodriguez added, Morgan, technical expertise plus courage is an extraordinary combination. The crew is completely behind you. Sarah donned the radiation protection suit, emergency repair kit prepared meticulously. Reactor compartment entry represented extreme risk, but absolutely no alternative existed. Morgan, Chief Thompson provided final technical briefing. Radiation levels estimated at 500 roentgens per hour. Maximum human exposure 15 minutes before permanent damage. Tools, procedures, emergency extraction plan ready. Completely understood, Chief. Repair sequence memorized, backup procedures planned, safety protocols acknowledged. The reactor compartment entry hatch opened slowly. Sarah's heart was pounding intensely, but determination remained absolute. 120 lives depending completely on successful repair completion. Radiation levels immediately spiked dramatically. Geiger counterclicking rapidly, exposure steadily accumulating. Primary coolant leak massive. Steam dangerously filling compartment. Visibility severely limited. Breathing apparatus essential. Movement restricted by heavy suit. Sarah used emergency flashlight to pinpoint leak location. Morgan, radiation status. Radio communication constantly maintained. Exposure steadily accumulating. Leak location visually confirmed. Accessing emergency patch kit. Leak source found quickly through technical expertise. Main coolant pipe extensively cracked. High-pressure breach creating extremely dangerous environment. Steam clouds, radiation field, time pressure enormous. Emergency patch application started immediately. Technical precision absolutely required, no mistakes tolerable. Training, knowledge, experience combining at critical moment. Morgan, timer running. 10 minutes elapsed. Patch placement in progress. Attempting primary seal, need additional time to complete. Working rapidly but carefully, Sarah utilized technical expertise to maximum. High radiation environment, limited visibility, extreme pressure conditions. Every movement calculated, every action purposeful. Steam clouds thickening, radiation exposure accumulating dangerously. Sarah focused completely on repair procedure. Life or death technical challenge, personal risk secondary consideration. 12 minutes of intensive repair work, patch partially successfully secured. Leak reduction visible, pressure slightly stabilizing, but complete seal still needed. Morgan, exposure limit approaching critically. Emergency extraction recommended immediately. Negative, Chief. Almost complete. Final seal needed, 3 more minutes required. Critical decision moment. Personal safety versus mission completion success. Sarah chose mission accomplishment. Personal risk fully accepted. Final patch application required perfect technical precision. Sarah's expertise maximum. Training complete utilization. Determination absolute. Repair completed successfully. Primary coolant leak sealed completely. Pressure stabilizing, temperature dropping. Emergency extraction from reactor compartment immediate. Sarah's radiation exposure significant but within calculated survivable limits. Mission completely successful. Disaster totally averted. Reactor power gradually restored. Propulsion systems available. Life support equipment stable. 120 lives saved through heroic technical expertise. Commander Mitchell returned to reactor control. Morgan, exceptional heroic performance. Submarine operations saved, entire crew lives preserved. Just performing duty, Skipper. Submarine service oath fulfilled. Chief Thompson's professional assessment. Morgan, technical expertise combined with courage is textbook perfect example. Reactor repair, flawless execution. Fellow crew members' attitude transformed completely overnight. Gender questions disappeared entirely. Professional respect universal. Technical competence proven beyond any doubt possible. Petty Officer Williams privately approached Sarah later. Morgan, sincere apologies for initial skepticism. Today proved absolute engineering excellence. Gender completely irrelevant in life or death situations. Appreciated, Williams. Submarine operations are always teamwork. Electronics technician Rodriguez added, Morgan, crew unanimous agreement. Technical expertise plus personal courage extraordinary. Submarine engineer excellence proven. Mission eventually completed successfully. Submarine returned safely to Norfolk Naval Base. Sarah's heroic action officially reported. Formal recognition procedures initiated immediately. Medical evaluation confirmed radiation exposure within acceptable limits, no permanent health damage sustained. Career continued, reputation permanently established. 2 months later, Pentagon formal ceremony. Sarah received Navy Commendation Medal for exceptional courage during submarine reactor emergency. Citation read formally, Lieutenant Morgan displayed extraordinary technical competence and exceptional personal courage during critical submarine emergency operations. Her decisive technical action and expert emergency repair work under extreme radiation exposure conditions saved 120 lives and preserved valuable naval asset. Secretary of Navy personally presented medal. Lieutenant Morgan exemplifies finest submarine service traditions. Technical excellence, personal courage, mission accomplishment. Sarah's story spread rapidly, Navy-wide. First female submarine engineer hero recognized. Gender barriers permanently broken through undeniable competence and courage demonstration. News media coverage extensive. Female naval officer saves submarine crew through heroic reactor repair. Currently assigned to Naval Reactors Program, teaching submarine emergency procedures academy-wide. Her practical experience informing training protocols, safety improvement implementations. Technical expertise recognizes no gender boundaries. She lectures new submarine officer candidates. Emergency situations require competence and courage, not social stereotypes. Sarah developed specialized emergency repair techniques, now standard submarine procedure fleet-wide, her innovation improving submarine safety operations globally. Speaking engagements at Naval Academy regular. Submarine service demanding but extraordinarily rewarding. Technical competence plus personal courage equals mission success always. Advanced submarine emergency procedures, development, current assignment. Her expertise directly shaping Navy policy future. From questioned competence to recognized technical authority, complete professional transformation. Sarah's story proves definitively. Technical expertise and courage transcend gender completely. When lives are at stake, competence alone matters. Her heroic courage saved 120 submariners, proved women belong in submarine service absolutely. Fellow officers now show her complete respect. Morgan proved excellence, conversations now respectful. Systematic approach reveals what others miss. Sarah began mentoring new submarine engineers. Technical pressure is normal response to complex systems. Key is systematic methodology despite time pressure, not rushing analysis. Technical challenges that once overwhelmed her are now manageable. Operational experience provided technical perspective impossible to achieve in training. Sarah's assignment statistics impressive. 89 critical system repairs, 1,456 successful maintenance operations, 0 safety violations. She became the division's most reliable technical expert. Morgan set standard for technical excellence, Chief Thompson reported. Other submarines specifically request Sarah for critical repairs. Currently assigned to Naval Technology Command, teaching advanced submarine systems, advanced reactor safety, emergency protocols, technical leadership methodology. Technical expertise is genderless, she lectures new engineers. Emergencies require competence, not prejudices. Sarah developed personal philosophy about technical challenges and engineering success. Technical pressure indicates recognition of risks involved. Systematic approach channels pressure into enhanced performance. Speaking engagements at engineering academies. In training, gender prejudices tried to make me fail. Technical competence succeeded operationally. The difference was systematic focus replacing prejudices. Sarah's story became case study in submarine engineering training. Overcoming gender prejudices in technical operations. Technical challenges, when properly approached, can become engineering advantage, she explained to engineering researchers. Enhanced attention to detail, systematic problem solving, comprehensive safety assessment. Currently developing new engineering training methodology emphasizing systematic approach over gender prejudices. Her operational experience informing engineering education policy. Sarah's transformation proved that despite gender prejudices, technical excellence can be achieved when properly developed and applied. The same prejudices that nearly limited her career ultimately led to saving 120 lives through technical expertise. Have you ever felt that your natural approach in your chosen field was wrong, then discovered that technical competence was exactly what was needed? Sarah often asks speaking audiences. This story honors the legacy of women who transformed their perceived weaknesses into life-saving strengths. It proves that technical expertise and courage have no gender.